Back to part two, we're going to go over some practice questions now using dimensional analysis. So we're going to do very much of a crawl, walk, brisk walk, just through the pace as we go through these. When you see the question come up, hit pause, and try to work out the question on your own, especially after we get through a couple of these questions. Try to see where you're at. And then if you find yourself getting stuck, you're like, man, I don't quite know what I would go or what I would do or where I would pick up from here. No worries at all. All you need to do is pause it. Okay. And then I'll pick up and you'll see exactly where it was that maybe you went wrong. I'll kind of give you some tips and tricks because most people get stuck right around the same places. Okay. All right. So some questions. First question says the primary healthcare provider orders furosemide Lasix 40 milligrams PO daily. You have 20 milligram scored tablets available. How many tablets will you administer per dose? So remember, the key thing is always read the entire question first, which we've done. The second part is I'm reading the entire question with typically one goal. I need to identify the stem. What is this question asking me for? In this problem, I know the stem is found right there in the last sentence. How many tablets will you administer per dose? It won't always be the last sentence. Sometimes it'll be in the middle. Sometimes it'll have a question mark at the end. Sometimes it'll just be a statement. Here it says, how many tablets will you administer per dose? That is exactly what I'm going to look for in this problem. So that means I'm going to start off exactly what we did before. I need tabs on the top and I need dose on the bottom. Write myself an equal sign, and whatever is in my numerator, I'm going to carry over to this side. And my numerator I start with. Okay. Spoiler alert. I'm never going to cancel out tabs because I need them on the other side of that equal sign. So the first thing I'm going to look for is tabs. So I'll go back to my problem. So the primary healthcare provider orders furosemide Lasix 40 milligrams, well, those aren't tablets, PO daily, 20 milligram scored tablets. That means each tablet is 20 milligrams. Whenever you see the term scored, that means that this tablet is able to be cut or divided in half or into equal pieces. Sometimes you can see a tablet scored in thirds, so you can give a third of the tablet. Capsules cannot be scored. The capsule is a pill-like form that has a powdery substance on the inside. You're unable to split that capsule in half without opening it up and the powder falling all over the place, right? So only tablets can be scored, and scored means I can break this capsule into a smaller equal unit. Most of the time they're half. When we talk about tablets, we typically do not round to the half unless the question tells us it is a scored tablet. If it's scored, I can absolutely give a half. If it's not scored, that means the way I broke it for my patient and where you may break it for your patient may not be exactly the same. And again, we're not in the business of practicing medicine by hoping and guessing. If we can't clearly see a line of demarcation where we can clearly break that tablet in half, then it's not scored and we can't administer a half tablet. That's your lesson on scored tablets. I have one tab that's 20 milligrams. I need tablets on my top and I need dose on the bottom, and these are milligrams. And milligrams and dose are not the same measures. I mean, I got to get rid of my milligrams. I already use these 20 milligram score tablets. You can only use the information once in dimensional analysis. Once I've annotated and found my one tablet for 20 milligrams, that's gone. Now I need to find some other milligrams. And this problem is telling me that I have 40 milligrams per one dose. You may be thinking, Coach, why is that 40 milligram per one dose? I don't see the word dose. I need you guys to write this on your paper somewhere on your notes. A doctor's order equals one dose. So in this problem, it says the primary healthcare provider, that's your doctor. It could be your nurse practitioner, right? It could be your physician's assistant. Okay. It could be whoever is writing the orders for your patient. It may say the doctor, it may say the physician. Just know whoever is writing that order is for one dose. Unless they ask you to calculate for the day, what we're solving for is one dose. What are we going to give the patient right now? What are we going to set the IV pump right now? How much medication are we going to draw up in our syringe to give right now? This is the dose. For the entire day, that would be the dosage, right? For the entire amount. Sometimes we need to calculate that. My patient's on strict eyes and nose, and yep, I need to know exactly how much fluid they're getting. So I want to know that beforehand. I can go ahead and do the math on that. If I'm giving them 10 milliliters 3 times a day, I know it's going to be 30 milliliters of fluid they're going to get from this particular medication. That will be for the entire day. That's the dosage. But your doctor's order here is clearly asking you for a dose. Okay. So that 40 milligrams PO daily, that's my doctor's order. So my doctor's order equals 1 dose. Right now I have milligrams, the units on the bottom and on the top. They cancel each other out. And now I end up with tablets on the top and my dose on the bottom. Multiply my bottom number first. 20 times 1 is 20. And 1 times 40 is 40. I take my calculator and divide 40 by 20. And that gives me 2. So my final answer is going to be 2 tablets per dose. I love dimensional analysis for a lot of reasons, but one of my biggest reasons is you can always check your work, okay? Just to make sure you set your problem up correctly. So if I look at this first one that says 1 tablet for 20 milligrams, is that true? I know that because that's exactly what it told me I had in terms of my score tablets. It told me I had 20 milligram score tablets, with each tablet being 20 milligrams. That's true. That's what I had available. And then my doctor's order was for 40 milligrams for 1 dose. That's what they wanted my patient to get. Okay, so that's my 1 dose. I know I set my question up correctly and I do my math. That's going to be 2 tablets per dose. All right, let's put that out and go to the next one. Number 2, an order is written for acetaminophen, Tylenol, 650 milligrams PO every 6 hours as needed for pain. The medication available is 325 milligram tablets. How many tablets are required for a dose? I read my entire problem. I identified my stem. They want to know how many tablets per dose. So start with my line. Tablets are going to be in my numerator, and dose is going to be in my denominator. I finished my setup. I'm going to put my tablets in the numerator because I have tablets in the numerator on this side of the equal sign. Okay. So I need tablets. When I go to read this question, there they are right there. It says the medication is available in, I don't have 325 tablets. I have 1 tablet that is 325 milligrams. I need tablets per dose, not tablets per milligram. So we're going to move our milligrams to the top. I stand my problem says the order is written for acetaminophen, Tylenol, 650 milligrams. There they are right there. Okay. So my doc says, give my patient 650 milligrams per dose. That is what the order means. The order is for 1 dose. That cancels out my milligrams. Now I end up with tabs on the top, dose on the bottom. Always check back with your destination after each step. Sometimes you'll arrive at your destination before you expect to. Sometimes you'll try to convert pounds and, convert kilograms into pounds for no reason at all. It won't be necessary. Okay. All because we kept working when we should have stopped a long time ago. Okay. So tablets per dose is what I got. Now I'm ready to solve. 350 times 1 is 350. 650 times 1 is 650. Ah, you gotta let me write that. Really? 36 there. The bottom. I was doing that math in my head. Like, that's not going to come up right. Okay, 325 times 1. Maybe I should use that in the calculator too. Okay, and over 650 divided by 325. Again, it's going to be 2 tabs per dose. Okay. Just in case you didn't believe me, there's an answer key. All right. Let's close those out. Let's do another one. So, another question you're going to have is, Coach, why didn't we use this every 6 hours up here? This one. Yeah, blinking. Why didn't we use that every 6 hours? I want you to write this at the top of your page as well. Over is for dose. Every is for day. So my saying is overdose every day. Overdose on love and joy and compassion and all the good stuff, right? Gratitude. So overdose every day. Whenever I see the question mentioning about over, that's typically in reference to the dose, which is what we're solving for most of the time. If I see the word every, or sometimes every may even be written as a Q, right? Every mean and Q means every, okay, in shorthand. So if I see a Q 6 hours or every 6 hours, I know that that is simply telling me how frequently are they going to get a dose. Okay. My final answer down here was 2 tablets per dose. That means my patient is going to get, if it is midnight right now, and the patient is going to get 2 tablets for this dose every 6 hours. So that means at 6 o'clock in the morning, guess what they're going to get again? 2 fresh tablets, and that will be the next dose. Guess what happens 6 hours after that? They're going to get 2 more tablets. You see how I'm never going to multiply or let that every 6 hours determine how many tablets I'm going to give them? No, that's to tell me the frequency in which they're going to get that dose. When does that matter? We said over is for dose, but every is for the day. If they would have asked me how many tabs per day is this patient going to receive, which is important sometimes, especially if your patient going to be going home and they're trying to figure out how many tablets of medication they're going to need to buy. Maybe they're trying to budget. Maybe got to get the social work involved. Who knows, right? But maybe we need to figure out how many tablets they need to take. Well, I'm simply going to set up my dimensional analysis just like this. I got my tablets on the top. I got day on the bottom. I'm going to carry over tablets. Okay. In this problem, still, 1 tablet is 325 milligrams, right? That's exactly what it's telling me right here. That didn't change. I don't need tablets per milligram. I need tablets per day. So now I'm going to move my milligrams up because they got to go. Still going to be the same. My doc wants my patient to get 650 milligrams. Now, because we're solving for the day, I'm going to use this every 6 hours. It cancels out my milligrams. But I don't need tablets for hour. I need tablets for day. So it's the hours I have to move up now. Okay. And there are no more mention of hours up here in this problem. In my data set, they didn't give me what I needed. I needed hours. I've already used these every 6. Those are gone. So there's no more hours up here. So guess what I have to do? You guessed it. BYOD. Gotta bring my own data. Because I know that there's a ratio. I know that there's a conversion that I can use that gets me hours today. I know that there are 24 hours in every one day. Now I have hours on the bottom and the top. They cancel out, and now I end up with my tabs per day. This is my tabs per day. I'm going to do the math on that. I have 325 times 6. Get out my trusty calculator. And that gives me 1,950. I clear my calculator and I multiply my top numbers. The reason why I do that is 90% of the time, your numbers on the top are going to be large. I want to make sure that my calculator is working with me and not against me. So I get 15,600. All I have to do is leave that number in my calculator, and I don't have to worry about adding an extra zero to 600 or forgetting an extra zero and making that 1,560. So all I have to do is leave that 15,600 in my calculator, simply hit divided by the 1950, chances for user error, and I get a whole 8. And that is going to be 8 tablets per day. That is exactly how many tabs my patient is going to get. Okay. Now, I know if we simply looked at, well, couldn't we just yep, you sure could. You could took the 24 hours and divided by 6. That tells you there's going to be 4 doses per day, and they're going to get 2 tablets for every dose. 4 times 2 is 8. There are a million ways to work these out. I'm showing you the long form way to do dimensional analysis, and you'll create your own shortcut. Just remember, if I teach you a shortcut and you shortcut the shortcut, you're going to get lost in the woods. Okay. We don't want to get you lost in the woods. I'm showing you the proper way to do all of these and how to set these up. The goal is to do them correctly. There is no bonus points for finishing first. There is a time limit, meaning we have to move with a purpose, but speed should not be our overarching goal. Accuracy. We have patients' lives in our hands. The order is for potassium chloride elixir, 30 milliequivalents. Those are 30 milliequivalents PO per mouth. The medication is supplied in a concentration of 40 milliequivalents per every 15 milliliters. How many milliliters will you prepare? So they're asking us how many milliliters we prepare. That's my stem. So again, I draw my line, start with milliliters on one side, Nothing on the bottom. It didn't say how many milliliters per hour. It didn't say how many milliliters per dose. So I only solve for exactly what the question says. It says, how many milliliters will you prepare? So it's mLs. Then I'm going to simply carry over to the other side. When I come to this problem, again, now I'm looking for milliliters. So the orders for potassium chloride, 30 milliequivalents. Nope. 40 milliequivalents. Nope. There we go. Per 15 milliliters. So the first thing I'm going to write is my 15 milliliters. And then I'm going to put my 40 milliequivalents right on the other side or underneath. Why? Because that's exactly what I had right here in my problem. I know you think, but wait, that said 40 milliequivalents per 15 mLs. How did you put the 15 on top? Because these are reciprocals, meaning there are 15 milliliters for every 40 milliequivalents. That means there's 40 milliequivalents for every 15 milliliters. It doesn't matter which one I put first, as long as I keep the corresponding number, the 15, next to the corresponding unit, the milliliters, because I have 15 milliliters and I have 40 milliequivalents. Doesn't matter which one I put first or which one I put after that or which one I put on the top or the bottom, as long as I keep the 15 next to the milliliters and the 40 next to the milliequivalents. Okay. So I can put the milliliters up top because again, I need my milliliters up top here. Now I just need milliliters in my final answer with nothing over here on the bottom. So I need to make sure that there's nothing on the bottom when I'm done on this other side. So I'm going to take my milliequivalents and move them to the top. Now I've already used these. Can't use those milliequivalents anymore. The order for potassium chloride. Oh, there we go. I got some more. 30 milliequivalents. PO. So let's take those 30 milliequivalents. And what am I going to put that over? The order is for potassium chloride elixir, 30 milliequivalents PO. That means the order is for my doctor's order is always 1 dose. I didn't have the word dose over here. Okay. Put it in parentheses because I know it's understood. That's what I'm solving for. This order is asking me for how many milliliters am I going to give to this patient? Well, that's their dose. Okay. My order is asking me for my doctor's orders for 1 dose. So 30 milliequivalents, that's 1 dose. Putting them both in parentheses because they didn't ask me to solve for dose, but now I know what this 1 down here is for. So I can get rid of this because again, I only solve for exactly what the question is asking me for. But just know that's what that 1 is. And also, in dimensional analysis, we're writing all these numbers as fractions. My favorite number is 12, right? 12 written as a fraction is 12 over 1. Okay, so in order to use 12 in this dimensional analysis, I would need to plug it in as a fraction. 12 would be my numerator, 1 would be my denominator. In these problems, we're not just grabbing 1 just because 1 either represents your 1 patient's weight, or in this instance, my 1 represents my 1 dose because my doctor's order equals a dose. That cancels out my milliequivalents on the bottom and the top. Now I'm left with just my milliliters, which is exactly what I need. My GPS says, ding, you've arrived at your destination. Get out the car and do some math. I got 40 times 1, 40. Yeah, 15 times 30, which I believe, let me 450. 450 divided by 40 is 11.25. Okay. And typically, according to your rounding rules of your school, we round our milliliters to the 10th. So it's going to be 11.25. We're rounding to the 10th. So that means the 2 is in the 10th column. I look to the right. The rule is 5 or more, we raise the score. 4 or less, we let it rest. Okay. So that is a 5. We're going to raise the score with it being 5 or more. So that gives us 11.3 milliliters is our final answer. Double check the key, and there it is. That's how we get that. All right, clear that out, and on to the next. This order is written for digoxin, 0.125 milligrams PO daily. The available oral elixir has a concentration of 0.05 milligrams per milliliter. How many milliliters will the nurse administer? Again, they didn't ask me for milliliters per dose, but I know it's understood. We're solving for the dose. Milliliters on the bottom and nothing. Oh, sorry, milliliters on the top and nothing on the bottom. Milliliters is what I'm solving for. Okay, there's my stem. I've identified my setup. Milliliters on this side equals milliliters on the other side. I need milliliters. The available oral elixir has a concentration of 0.05 milligrams per milliliter. I just need to keep the numbers next to the corresponding units. And it tells me I have 1 milliliter. Don't make the mistake of putting that 0.05. That goes with the milligrams next to the milliliters. 0.05 milligrams for every 1 milliliter. I can put the milliliters on the top and the milligrams on the bottom and flip them because they are reciprocals. In my final answer, I need milliliters on the top. There's nothing over here on the bottom. So I need to ensure that I don't have anything on the bottom when I start working my problem on this other side. So that means I have to get rid of my milligrams. That's correct. Okay. So I go back to this problem. I need milligrams. I've already used these. Those 0.5 per milliliter. I can't use those anymore. Thankfully, the order is written for 0.125 milligrams. So I have 0.125 milligrams per. That's my 1 dose. Again, my doctor's order. This is what was ordered for my patient. My doctor's order is always for 1 dose. To get rid of my milligrams on the bottom. And we have milliliters on the top. Right. So now we can get out the card because you've arrived at your destination. Let's do some math. 0.05 milligrams times 1 is 0.05 milligrams. 1 times 0.125 is 0.125. Grab my calculator again. Okay, I have my 0.125 divided by 0.05. And we are going to give a whopping 2.5 milliliters. That's how much the nurse is going to administer. And that's how we got there. Now let's talk parenteral medications. Parenteral being around around the enteral route, so around the GI system. So this is going to be your injections, your IV, anything that's going outside or around the GI tract will be parenteral, mostly your injections. Okay, so the client requires morphine sulfate 6 milligrams IM for severe pain. The medication available is a vial labeled 10 milligram per milliliter. How many milliliters will you draw in the syringe? Okay, first thing to do is identify your stem. What's our destination? How many milliliters? Milliliters equal sign milliliters. That's my setup that I do on every problem. It keeps me on track and I never get lost in the sauce. Okay, so I'm still looking for milliliters. There they are. The medication is available in a vial labeled 1 milliliter for every 10 milligrams. This is what was available to me in the pharmacy, or it came up from the pharmacy in my nursing cart. 1 milliliter for every 10 milligrams of that medication. I just need milliliters in my final answer, which I have up top, but I don't need milligrams on the bottom. So the milligrams are going to move up now to get them to cancel. I've already used these 10 milligrams. I can't use those anymore. But lucky for me, the client requires morphine sulfate 6 milligrams. That is my doctor's order. And that is what my doctor's ordered for my patient to get. 6 milligrams per my 1 dose. It cancels out my milligrams. And now I'm left with just milliliters on the top. You've arrived at your destination. Get out the car and do some math. 10 times 1 on the bottom is 10. 1 times 6 on the top is 6. 6 divided by 10 is 0.6. So my patient's going to get 0.6 milliliters. The longer we're here in nursing school, we'll know that answer makes sense because if it's anything greater than 3 milliliters, I'm probably going to be calling the doctor, the pharmacy, trying to get that order. Change the switch because I can't safely administer that medication without causing harm to my patient. So this is where a dosage calculation matters. Remember, as I'm going through these, feel free to pause before I start working the question, and you can start to work these out on your own. Then click play and see if you're on track or not. Or if you find yourself getting stuck, just unpause it and I'll pick up right where you need me to. Okay, so the order reads methylprednisone or Solu-Medrol 80 milligrams IM. The pharmacy has supplied a vial with a concentration of 125 milligrams per 2 milliliters. How many milliliters will you administer? We know that our stem is milliliters, so let's see exactly what we're going to solve for. It's milliliters. According to this problem, how many milliliters? We got our setup, milliliters, carried them over, milliliters. All right, look at this problem. I got to find some more milliliters. Thankfully, that's what the concentration is that came up from the pharmacy. Means pharmacy's already done their job. There's no reconstitution needed. They sent it to us in the final concentration already. We didn't have to do anything to the vial at all. Okay, we're going to pull these 2 milliliters out of there. And I put those with the 125 milligram. Okay, because this is what came up from the pharmacy. That's what was available to us. 2 milliliters for every 125 milligrams. Why did you start with 2 milliliters, coach? Because right here it tells us this is what the pharmacy sent us. It was a 2 milliliter vial that had 125 milligrams already mixed inside of it. I put the milliliters on top because I have milliliters on top of my final answer. Keep the two next to the milliliters because the two is next to the milliliters in my data set. I don't need milliliter per milligram. I just need milliliters. So it's the milligrams I need to move up and get rid of. Thankfully for us, the order, which we know is 80 milligrams. Okay, the order's in milligrams, so there's no conversions or anything needed. I got 80 milligrams per one dose. I don't need to write the word dose because the word dose is not on the left side of the equal sign. So I know that that one represents my dose, but don't need to write the unit or the label because it's not labeled on the other side. They didn't ask me for milliliters per dose, but essentially we know that's what we're solving for. Okay, so now I've arrived at my destination. Let's do some math. 125 times 1, 125. Okay, 2 times 80 is 160. Pull out my trusty calculator again. And I know that 160 divided by 125 equals 1.28. And we're going to round this to the 10th. So there's my 10th. I look to the right. 5 or more, we're going to raise the score. That tells me I'm at 1.3 milliliters. And that's exactly what my key says. So it must be right. And remember, I can always come up here and check. Did I set my problem up correctly? Yep. I know that 2 milliliters, there's 2 milliliters for every 125 milligram. That's what was available in my problem. So that's correct. And I know that my one dose is 80 milligrams. Why? Because that's exactly what my doctor put for my patient to have up top. That's my doctor's order. So I know those are correct. As long as I plug the data in correctly, I know it's just a matter of me using the right numbers on my calculator, which we did. Easy. On to next. Okay, now we're going to talk about your fusion pumps. Sometimes they'll tell you to calculate the flow rate. Other times they'll tell you calculate milliliters per hour. Sometimes they'll say calculate drop per minute. Okay, all of those involve either you manually counting out the drops or using a infusion pump or calculating the flow rate. Okay, so it says you will need to infuse 1,000 milliliters of 0.9% sodium chloride. Remember that 0.9% is just the name of the fluid. We don't do anything with those numbers. Over the next 8 hours using an infusion pump. At what rate in milliliters per hour will you set the pump? That's what we're going to solve for. I have the mLs on the top, R's on the bottom in my denominator, and my equal sign, and it's just the milliliters that we set up with. Okay, so now I'm going to be looking for milliliters. And thankfully, my doc gave me an order for 1,000 milliliters. That's what we're going to administer. Okay. Now it says 1,000 milliliters of 0.9% sodium chloride. There's my word over the next 8 hours. Okay. So again, I'm solving for the dose. So I'm going to use those 8 hours. Okay. This again is why it's so important. Always double check your destination. We need milliliters on the top. We got that. We need hours on the bottom. You've arrived at your destination. Get out of the car and do some math. Okay. So we don't need to go any further. It was just that simple. 1,000 divided by 8 is 120. 125 milliliters per hour. That is where we're going to walk into our patient's room. We're going to find their IV pump, the one that understands milliliters per hour. I'm going to walk in their room. I'm going to go 1, 2, 6. I'm going to delete that and go backspace. 1, 2, 5. And then I'm going to hit start. And that pump is going to deliver 125 milliliters of fluid every hour. Right? That's what that pump's trained to do. It's my job to figure out what numbers to put in there for the rate, and the pump will handle the rest. Okay. On to the next. Here we have a client to receive piperacillin or Zosyn, 3.375 grams in 100 milliliters of D5W IVP, which is IV piggyback. It means we're going to have a smaller bag hanging the same time as a larger bag, but the smaller bag is going to be higher. And whichever bag is higher, gravity does this awesome thing where it's going to pull from the smaller bag first. And once that one's done, the lower bag for your maintenance fluid kicks back on and there's no area line. IV piggyback system is awesome. Okay. So IV piggyback over 45 minutes. At what rate in milliliters per hour will you set the infusion pump? Again, we are solving for milliliters per hour. We are not confused by the D5W. We know that's just dextrose 5% in water. So what we're solving for, milliliters on the top and hours on the bottom. Okay. Carry over my milliliters. And in this problem, it tells us we have 100 milliliters. And you may be tempted to use these 3.375 grams, but we're not going to use those. In this problem, let's switch up colors. Just makes better sense if I put blue is in blue. Okay. So we got an IV bag. In this IV bag, we have 100 milliliters of fluid. This is all blue. It's all fluid in here. Okay. You know what else we have in this bag? 3.375 grams of this medication. So these are the medicine that's been diluted inside of this bag. Everywhere this 100 milliliters goes, that 3.375 grams of medication goes. I'm not going to put 3.375 grams down here at the bottom. That's a decent ratio, but I need milliliters per hour. I don't need milliliters per gram. The moment I try to get rid of my grams, well, there's no more grams up here in this problem. There's not even really milligrams. There's nothing for me to even convert grams into. And what I need on the bottom is hours. There is no conversion that converts grams into hours. Not that we're concerned with. Okay, so we're not going to use that 3.375. That's not where that goes. Instead, what we're going to use is this, there's my word, over again, right? So it's literally going to take that same bag, this entire bag right here, the whole thing is going to be infused over 45 minutes. So again, this 3.375, it's in the bag already. I don't need to worry about it. Everywhere that 100 milliliters goes, those grams go with it. This whole bag is going to be infused over 45 minutes. So that's why I have 100 milliliters over 45 minutes. Now remember, I need hours on the bottom here, okay, not minutes. So it's the minutes that I have to get rid of. There's a conversion. That tells me it's 60 minutes for every 1 hour. That gets rid of my minutes, and now I'm left with milliliters on the top, which I need, and hours on the bottom, which I need. Ding. You've arrived at your destination. Get out the car, do some math. 45 times 1 is 45. 100 times 60 is 6,000. 6,000, leave that in my calculator, divided by 45 gives me 133.3 repeating. Okay, I'm going to round that to the 10. This is the 10. Look to the right. 4 or less, we're going to let it rest. So 133.3 or 133. Same thing. Right. So again, we do not need that grain. That 3.375, it's out of there. We don't need that. It's in the exact same bag as the fluid. So that 100 milliliters over 45 minutes, that's what we're actually going to solve for. Okay, and there's our 133. Okay. We'll figure that out. And on to the next. You are to infuse 1 liter of D5W over 10 hours. The manual IV tubing has a drop factor of 15 drops per milliliter. How many drops per minute, ET per minute, will you regulate for the infusion? And this is just a freak accident because the lines added up. These two have nothing to do with one another. So please don't confuse that. Okay. What we're going to solve for is how many drops per minute will you regulate for the infusion? So that means I'm going to start with my drops on the top and my minutes on the bottom. Finish my setup. You guessed it. Drops on the top. Okay. So when I go looking into this problem, there was my drop factor. Drop factor just tells me how big is this tubing that we're using. These are some pretty big drops. It only takes 15 of these drops to equal 1 milliliter in this tubing. Okay, so that's information for my drop factor. That's where that came from. Okay, I don't need drop per milliliter. I need drop per minute. What's the milliliters? And I'm going to move up. You are to infuse 1 liter over 10 hours. None of those are milliliters. And I've already used these, so I can't use that one anymore. So there's my cube. They didn't give me any more milliliters, but what they did give me was something that I convert from. So I had to BYOD, and I have to know walking into this exam that there are 1,000 milliliters for every 1 liter. You have to bring your own data when they don't give you the info you need. So that cancels out your milliliters. Now I have drop per liter, but I need drop per minute. The reason why we converted those milliliters into liters is so we can use this liter up top. That means 1 liter is going to go over, there's my over word, over 10 hours. Okay, that cancels out my liters because they're on the bottom and the top. Okay, but now I have drops per hour. I don't need drop per hour, I need drop per minute. So now it's the hours I have to move up. Did they give me any more hours? Nope, we've already used those 10 hours, so there's no more hours mentioned. So guess what I got to do again? So to bring my own data. If there's a conversion to help me go from hours to minutes, and that's 1 hour for every 60 minutes. Now my hours on the bottom and the top, they cancel each other out, and I'm left with drops per minute. Okay. Ding. You've arrived at your destination. Get out the car, man. Let's do some math. 10 times 60 is 600. On the bottom, 15 times 1,000 is 15,000 divided by 600. 25 whole drops per minute. Okay. And I say whole drops for a reason because this was 25.5. I can't have half of a drop. So then I would go to 26. Okay. That would have been 25.4. Then 4 less, we let it rest. It still would have been 25. All right. On to the next. All right. So an IV is regulated at 40 drops per minute using 10 drops per milliliter tubing. How many hours will it take for 1,000 milliliters to infuse? Now we're trying to figure out how much time do I have with this bag? As a nurse, we don't want my patient's IV fluids to run out. So to be able to anticipate problems before they happen means I may need to do a little bit of math to figure out how long are these fluids going to last. And what they're asking me for is how many hours will it take? Okay, so what I'm going to solve for hours to start. No different. You know, like, well, wait a minute, we never solved for time before. Start with exactly what it is you need. They're asking us to solve for hours. That's what I'm going to start with. Guess what? They don't give me any hours, but I don't fret. But I know they gave me minutes up here. I know I can get from hours to minutes using my own data. So I want to BYOD, and I'm going to say the 1 hour, 60 minutes. Okay. I don't need hours per minute. I just need hours. So it's the minutes I need to get rid of. And now I can use those 40 drops per minute. 1 minute is going to yield 40 drops with the type of tubing that I'm using. This is our drop factor. Size of the tubing. Minutes on the bottom, minutes on the top, they cancel. And now I have hours per drop. I don't need hours per drop, I just need hours. So we need to move the drops up. According to this, we have 10 drops per 1 milliliter. To get rid of my drops on the bottom, drops on the top. Well, now I have hours per milliliter. I just need hours, so we're not done. And now, actually, I confused you guys. This is my drop factor. This is my rate. Okay, that's my flow rate. So 40 drops for every 1 minute. That's the rate at which my fluids are going to be running. A drop factor was my 1 milliliter for every 10 drops. Again, still some pretty big drops. But I don't need hours on the top and milliliters on the bottom. I just need hours on the top. So again, it's the milliliters I need to get rid of. And they tell us that it's going to take 1,000 milliliters. Okay, that's how many milliliters we have to infuse. So that's 1,000 milliliters. What my doctor wants my patient to get is 1,000 milliliters. So we know that's my 1 dose. They didn't ask me for hours per dose. They just simply asked me for hours. So it's going to cancel out my milliliters, and all I'm left with are my hours. So I'll do my math. 60 times 40, 2,400. Figure that out on my calculator. 1 times 1 times 10 times 1,000. It's 10,000 divided by 2,400. Leaves me with 4.1666, repeating for forever. We're going to round that till the 10. 1 is in 10th place. I go more, we're going to raise the score. So that leaves us with 4.2 hours. If we had to solve this for hours and minutes, all we're going to do is take the whole number, which is 4. So that would be 4 hours. And then what we had remaining was the 1 666, repeating for forever. What we do is we take that number and I multiply that by 60, and that will tell me how many minutes I have. If I take that in my calculator and I multiply that 0.1666666, repeating forever, right, times 60, and that tells me that it's going to be 10 minutes. That's all we did. So we had 4 hours. Okay, and then we took whatever was left over here, 0.1666. So we have up here at the top, multiply that by 60, and that gave us 10 minutes. So that would be 4 hours and 10 minutes, or 4.2 hours, whichever way we want to solve that. The nurse needs to figure out how many milliliters will the patient receive in 8 hours. 8-hour period, excuse me. The IV is regulated at 50 drops per minute using 10 drops per milliliter tubing. How many milliliters will the client receive? That is our stem. So again, we're going to solve for milliliters, very similar to the one that we just did. We're looking for milliliters first. We have 1 ml for every 10 drops. That's our tubing, so drop factor. Move our drops up because we just need milliliters. There's our drip rate right there, 50 drops for every 1 minute. I don't need milliliters per minute. I just simply need milliliters. So we have to find a way to get rid of these. So they did not give us any more minutes, but they did give us hours. So I know can't use 8 hours yet because I have to get these minutes into hours. That means it's 60 minutes for every 1 hour. Now I have milliliters per hour. Don't need milliliters per hour. I just need milliliters. So I get my hours to cancel, and now we can use those 8 hours. Okay, because that is the time frame that they're going to get these fluid. Okay, that's a part of my doctor's order. So that is my 1 dose. It's going to be given over these 8 hours. That cancels out my hours, and now I'm left with exactly what I need. Milliliters on the top. I'll do my math. Okay, 1 times 50 times 60 times 8 is 24,000. Divide that by 10. And that's going to be 2,400 milliliters of fluid that my patient is going to receive. Okay, in those 8 hours. And that's how we solve for that volume. So we just had one we solved for the time, and then we just flipped it, and now we solve for the total amount of fluid in milliliters. Right. And out of there and on to the next. So your clients to receive a continuous IV antibiotic at 1.25 grams per hour. You have on hand 500 milliliter bag of LR, lactated ringers, with 2.1 grams of medication added. Using an IV infusion pump, calculate the flow rate. What are we solving for? Remember, we said the flow rate is a volume over a time frame. So that could either be milliliters per hour or drops per minute. We don't have any drops, so we cannot solve for milliliters per hour. In this problem, we have 500 milliliters for every 2.1 grams. Now you're thinking, wait a minute, we didn't use the grams last time. Why are we using grams this time? In a cursory review of my question, I can see that your clients to receive a continuous IV of antibiotic, 1.25 grams per hour. So those units I'm going to be able to cancel. So 1.25 grams cancels out my grams. And now I'm left with milliliters per hour. That's 2.1 on the bottom, and then 500 times 1.25 on the top is 625, which we're going to divide by 2.1. And that equals 297.61. Okay, we're going to round that to the 10. That's my 10. Look to the right, 4 or less. We're going to let it rest. 2.97.6 milliliters per hour is what we're going to give this patient. If we round to the whole number, it'd be 298 milliliters per hour. All right. Clear that. On to the next. The order is for LR, lactated ringers, at 55 milliliters per kilogram over 24 hours. This is a divided dose question. Your client weighs 95 pounds. You are to administer half of the total amount over the first 8 hours and the other half over the next 16 hours. Using a drip factor of 15 drop per milliliter, calculate the flow rate in drops per minute for the first 8 hours. So what they're asking us for is to calculate the flow rate. It seems like a lot of information, but we always start with exactly what we're looking for, which is going to be drops per minute. Finish my setup with drops. Okay, so in this problem, it tells me my drip factor, the size of the tubing that I have, they are 15 drops for every 1 milliliter. I need a drop per minute. What's the milliliters I need to move up? Okay, and in this problem, I've already used these 15 drops per 1 milliliter. So I'm going to move up to these 55 milliliters. This is my doctor's order up here. It's 55 milliliters per 1 kg. Kg is short for kilogram. And then it says over 24 hours. This is a divided dose question. So I'll need to know that this over 24 hours means a day. So that's what I'm going to write in my equation. No, the 24 hours is the complete unit of measure, right? So just to make it simpler on myself, I'm going to just go ahead and write the word day. So the way we write that is 55 milliliters per kilogram. The milliliters are in the numerator, like 1 kilogram within the denominator, and then the 24 hours of the day in the second part of the denominator. So there's 2 units in the denominator of this question. 55 milliliters per kilogram or per day. It's essentially what that's saying in that box right there. So this is how I plug that in. Okay. So again, we have milliliters that we need to get rid of. The question says 55 milliliters per 1 kilogram over a day. Okay, you'll see why we write the day like that when we get a little bit further into the problem. Okay, I have milliliters on the bottom, milliliters on the top. They cancel each other out. But I have drops per kilogram per day now, right? So I need minutes. Neither one of those are minutes. So I know that I'm going to need to get rid of both of those. But since kilograms came first, let's get rid of the kilograms over here. So go back to my problem. They do not give me any kilograms. What they gave me were pounds. So I don't say 1 kilogram is 95 pounds, right? That is not a true statement. That is not what we're doing. We are going to do pounds. Remember, this is my BYOD. This is my own conversions, my own data. 1 kilogram I know is 2.2 pounds. So that gets rid of my kilograms on the bottom here and on the top there. But now I have drop per day per pound. Let's get rid of the pounds. Now I can use my patient's 95 pounds. What are we going to put that over? 1. That 1 does not mean dose. That is my 1 patient's weight. A 1 patient weighs 95 pounds. They don't weigh 95 pounds per day. They don't weigh 95 pounds per hour. They don't weigh 95 pounds per second. They just simply weigh 95 pounds. It's my 1 patient. So that cancels out my pounds. But now I need to still get rid of this day over here. I have drops on the top. Those are never going to get canceled. But I need minutes on the bottom. Right now I have day. So I move my day up. Now in this problem, I know you're thinking, all right, why are we not going to use those 16 hours? Well, we're not. Because the time frame that I care about is going to be 8 hours. We need for the first 8 hours. So this is a divided dose question. In this one day, we're dividing it up into 2 doses. One day, this patient is going to get 2 doses. Half of it is going to be over the first 8 hours. The other half is going to be over 16 hours. The half that we care about is the one we're going to solve for. So now I had day on the bottom and day on the top. They're gone. Okay. Well, now I have the drop per doses, but what I need is drop per minute. So I know that the 1 dose that I care about is going to be administered over these first 8 hours. Okay. That cancels out my doses. But now I have drops per hour. I need drops per minute. Okay. Get rid of the hours. Convert those to minutes. 1 hour, 60 minutes. Now I have my drops on the top and my minutes on the bottom. Everything else has been canceled out. Okay, let's do our math. We got 2.2 times 2 times 8 times 60. That's 2,112 for my denominator. 15 times 55 times 95 times 1 times 1 times 1 equals 78,375 divided by 2,112 equals 37.109. And we're going to round that to drops. Okay, so more or less, we're going to let that rest. So it's going to be 37 drops per minute. Remember, I can always go back and double check my work, especially in a long problem like this. I'm going to make sure I didn't get off track anywhere. This is going to be the step right here, well, these two that are going to trip most people up. Okay, we started out with our drop factor, 15 drop per milliliter. Okay, it's exactly what it said we had here. True. Okay, my doctor's order was for 55 milliliters per kilogram of my patient's body weight over a day or 24 hours, milliliters per kilogram per day. 1 kilogram is 2.2 pounds. All I'm doing is double checking myself, making sure I didn't put 2.2 kilograms as 1 pound. Sometimes we move a little quick and we flip those numbers, but that's true. This is why I double check. And it's also true that my patient weighs 95 pounds. Yep, it's exactly what that says up here. On my doctor's order, my doc says I want to give them a divided dose. Half is going to go in this time frame. The other half is going to go over this time frame. That tells me in one day, they're getting 2 doses. The one dose that we care about, that my doc says he wants administered, is going to be given over those 8 hours. So the one dose over 8 hours, and then we had the BYOD again here for 1 hour is 60 minutes. All those are true. So we know our setup is good. So we just simply need to do our math. And that's why we got the calculator. Okay. That should definitely say 30 seconds. All right. Clear. And on to the next. Another divided dose question. So we just solved for 8 hours. This one looks like they want us to calculate for the next 16. So the order for lactated ringers at 112 milliliters per kilogram over 24 hours or per day. The client weighs 44 kilograms. You are to administer half the total amount over the first 8 hours and the other half over the next 16 hours. The first 8 hours is complete. Just the next 16 hours we're going to solve for. Calculate the flow rate in drops per minute for the next 16 hours using a drip factor of 10 drops per milliliter. Calculate the flow rate in drops per minute. That's what they want us to solve for. So again, my drops over here. My minutes on the bottom. And we'll solve for drops to start with. So we get our drop right here in our drop factor or drip factor. Same drops per 1 milliliter. I don't need drop per milliliter. I need drop per minute. So I'll simply move my milliliters. Tells me up here I have 112 milliliters per 1 kilogram of my patient's body weight per day. 24 hours. I know in a divided dose question, that's a day. Milliliters on the bottom, milliliters on the top, they don't cancel each other out. Now I have drop per kilogram per day. I need drop per minute. Let's get rid of the kilograms first. Do not make the mistake of trying to convert this. Okay. If you do this, that means you did not double check your problem. They gave you the weight in kilograms already. So we don't need to do this. We don't need to bring our own data. The data from the question is good enough. Okay. So no BYOD needed right here. What I'm going to do is simply move my kilograms up. I'm going to take the 44 kilograms in the problem. What are we putting that over? 1. It's my 1 patient's weight. Okay. Then I have drops per day. I need drop per day. I need drop per minute. So it's the days we got to get rid of. 1 day is going to be 2 doses. Why? Because it's a divided dose question. They already gave 1/2 of it. That's 1/2 of the dose. Now we got to give another. Okay. There's my day. Now I have drops per dose. Move the dose up. My 1 dose is going to be given over 16 hours this time. That's the one that I care about. Okay. So again, don't need those 8 hours anymore. It's the next 16 that we care about. Okay. And let's see if that's right. 26 drops per minute. Thanks. That gets rid of my dose. This is drops. Those are hours. I need minutes. So still not done. We're going to pull our hours up. There's no more hours. We're not going to use those 8 hours. Those are already complete. Those are gone. So there's no more hours for us to use. We need to convert those to minutes. B by D. Cancel my hours. Now left my drops per minute. 1 times 1 times 1 times 2 times 16 times 60. And we get 1,920. Now we have 10 times 112 times 44 equals 49,280 divided by 1920. We end up with 25.66. Repeating, round that to the whole number because we can't have a sixth of a drop. Here's our whole number. We look to the right. That's 5 or more, so we got to raise the score. 26 drops per minute. Right. Next one says the nurse practitioner prescribes the Joxin 0.25 milligrams PO by mouth. Pharmacy has available 250 microgram tablets. Pay attention to those units. How many tablets will the patient receive? Round to the nearest whole number. Okay. And there's my setup. All right, first thing I'm looking for is tabs, and tells me the pharmacy has sent 250 micrograms per tablet. So that means each or one tablet is going to be 250 mcgs. Remember, micrograms are the really small units. I just need tablets, not tablets per microgram. So we got to get those to cancel. And they do not give me any more micrograms. A milligram is what this is. Okay. It's not a microgram. So I have to convert. I know that there's 1,000 micrograms for every 1 milligram. That's going to cancel out my micrograms. Well, now I'm at tablets per milligram. It's the milligrams I need to get rid of. Okay. Now I can use these 0.25 milligrams. That cancels out the milligrams, and now I'm left with just tabs. It's exactly what I need. 250 times 1 is 250. 1,000 times 0.25 is 250. That means my patient's going to get a whole 1 tablet. I put it out so you can see it. There you go. Okay. And this is one of the last ones. Sometimes you may see questions that have medication labels, so we'll show you these, and then I'll do a couple reconstitution, and then we'll be done. Okay. So the primary care provider orders Demerol, 60 milligrams IM intramuscular. Now, use the label as the available medication to prepare this medication. How many milliliters will the nurse administer? Okay. So let's look here. mLs. That's my setup. Okay. So first thing I'm going to look for are milliliters. How many milliliters? Well, we're solving for milliliters down here. Okay. I use this label. Now you notice there's a couple different milliliters on this box. You have one down here that says 25 times 1 mLs. This is telling you the quantity of single dose vials that are inside of this box. I don't care how many are inside of this box. What I care about is this 25 milligrams per milliliter. This is the concentration. This is for inside of each one of these 1 milliliter single dose vials, there's a concentration of medication. Okay. The medication's in a little vial. Looks like this. Okay. It's got some powder in it. Okay. And fluid. The powder and the fluid are mixed. These are your stars. These are 25 milligrams mixed inside of every 1 milliliter of fluid inside of there. Okay. That's what this label is saying. I know it ain't as pretty as the label, but that's what it's saying. Inside of that vial, you have for every 1 milliliter, there's 25 milligrams of medication. We just need milliliters. So we have to plug in our 1 milliliter that we have from the box, 1 milliliter for every 25 milligrams. I don't need milliliter per milligram, so I have to get rid of the milligrams. And now we're going to use this 60 milligrams right up here. 60 milligrams. And what are we going to put that over? So I must know that this must be my doctor's order. And my doctor's order is always for my 1 dose. Okay. Those two cancel. And now I'm left with my milliliters, which is exactly what I need. 25 times 1 is 25. 60 times 1 is 60. 60 divided by 75 is 2.4. So my patient's going to get 2.4 milliliters of that medication to get the required dose. Okay. All right. Let's talk about reconstitution. All right. We ain't done yet. So practice question for reconstitution. The order is to administer ampicillin 500 milligrams IM. The direction for reconstitution state 2-gram vial state and 2.8 milliliters of sterile water to yield a final concentration of 400 milligrams per milliliter. How many milliliters will you administer? A lot of data. Still going to start with the same thing. What is this question asking us for? Milliliters. Okay. That's what we're going to start with. Now, whenever you see the word reconstitution, all this word means is we got to do some work for the pharmacy. Pharmacy must have been busy or they didn't have time to mix it for us. So we have to mix it when we get to the floor. They give you very explicit directions right there on the package insert. It tells you to reconstitute, which means we have 2 vials. One vial has powder in it, 2 grams of it. And another vial has fluid in it. We have to add this 4.8 milliliters of fluid into this vial. When we do that, we're going to get a final concentration inside the final vial of 400 milligrams per every 1 milliliter. This is the result of these two being added together. It is the final concentration we care about because these no longer exist once we reconstitute them. This is no different than Crystal Light. You take a Crystal Light packet and a water bottle. The Crystal Light packet in this instance would be your medication or the powder. Your reconstitution or your liquid is going to be the water. Once I take the Crystal Light and I dump it inside the water, they no longer exist independently. They are now one solution. That one solution has a concentration. In this problem, it is 400 milligrams for every 1 milliliter. Those are the numbers that we care about. So it's 1 milliliter for every 400 milligrams. Okay. We're solving for how many milliliters? That means I got to get rid of these milligrams. I've used that data. I can only use the data one time. So I can't use that anymore. But I need to get rid of these milligrams. So again, this data is gone as well. It's already been mixed together. My doctor has ordered 500 milligrams per 1 dose. Remember, that's my doctor's order. So that equals 1 dose. It cancels out my milligrams. And I've arrived at my destination. Milliliters on top. 1 times 500. 500 divided by 400 equals 1.25 milliliters. So that medication is what my patient is going to get. We round that up. It's going to be 1.3. So I should have been 1.25. Which equals 1.3. Okay. And remember, reconstitution simply means I'm going to take this powder and I'm going to add in some fluid. Once I do that, I have my final concentration. This is the one I care about, the 400 milligram per milliliter after I've mixed or reconstituted it. Okay. Just doing a little bit of extra work for the pharmacy. That's it. All right. And one more. So the client is to receive Mafoxin 1 gram IV piggyback. The direction for reconstitution, the 1 gram vial state to use 10 milliliters of sterile water, which will result in a final concentration of 1,000 milligrams per milliliter. How many milliliters will you draw up? Okay, so we're solving for milliliters. That's my stem right there. So I'm looking for my milliliters. Remember, this is reconstitution. So this started off as powder and we mixed in 10 milliliters. Both of those no longer exist because what I have now is my final concentration. That's what I care about. Okay, so my 1 milliliter is 1,000 milligrams. Okay, I don't need milliliter per milligram. My final answer is just milliliters. So we gotta get rid of the milligrams. And we know that there's a relationship between milligrams and grams. That's 1,000 milligrams for every 1 gram. Now I have milliliters, which I need I have grams, which I don't. So I gotta move my grams up. They tell me that my doctor has ordered 1 gram for my patient. So that's my one dose. So 1 gram over one. Now it cancels out my grams, and now I'm left with just what I need. Milliliters on the top, milliliters on the top. We've arrived at our destination. Get out the car and we'll do some 1 times 1 is 1,000. 1,000 times 1 again is 1,000. So my patient's going to get a whopping 1 milliliter. Okay. All right. That, ladies and gentlemen, are some of the basic questions for dosage calculation. You can feel free to watch this as many times as you need to. I promise I'll be just as patient the second time through, or the third or fourth or fifth time. Just remember, these are going to take reps. We're not going to get this down after just doing it one time. This is the crawl phase. We're just now getting our stride. So give yourself a little bit of grace. Go back through, work multiple questions, use the practice package that your instructors probably gave you in class. Even if you use a different way before, go back and try to work those same ones with dimensional analysis. Oftentimes, you may find yourself wanting extra questions. You can get additional questions from the original question after you worked it out the first time. If the doctor's order was to administer 500 milligrams, make the question, the doctor has ordered 1,000 milligrams. The doctor has ordered 500 milligrams and cut it in half. Now the doctor's only ordered 250 milligrams. So guess what your final answer is going to be? Half, right? So all you need to do is if you tweak the doctor's order and don't change anything else, then you have an answer key already for the next couple questions. And that's all you need in order to work through these questions, is to get the reps, to get the practice. Okay. Also, ChatGPT is amazing for creating questions. Just make sure you double check the answers, because it will give you some bogus answers sometimes. So remember, garbage in, garbage out. So you got to make sure you're verifying and be very specific in your prompts and details if you're going to use that. That'd be a good way to, like technology, make as many practice questions as you need. Okay. So our objectives: I want to recognize the purpose of dosage calculation. We are fully licensed nurses at the bedside. Oftentimes, we're the safety net for the entire healthcare team, making sure that my patient doesn't get more or less than what they should have. We don't want to be giving non-therapeutic doses of medication, especially when it comes to antibiotics. We know that can be tragic. Okay. We also want to identify the pertinent information. There are times we're going to use the data in the problem, other times where we got to bring our own data. There's other times where there's going to be excess data in the problem, like in reconstitution questions, where we don't need that data at all. So we need to identify what we're looking for to make it a lot easier to help us select what we need out of that problem. Okay. And then we solve some simple dosage calculation problems using dimensional analysis. Please practice this. Practice does not make perfect. Perfect practice makes perfect. You can practice something the wrong way, you're not going to get any better at it. You just got really good at doing it wrong. So you want to practice it the correct way. Remember, these are the long form way to do these questions. There are shorter ways to do them, but I highly recommend you work them out the long way and then create your own little shortcuts down the line. This is only after you become more proficient. With that, I bid you all adieu. I thank you for your time. Until next time.
And that concludes our broadcast day.